Hello, hello. Today we are talking and demonstrating spatial relationships and joins. Some super important concepts and I would say intermediate concepts in vector GIS operations. We'll do a little mini lecture and then conclude with a tutorial. So let's get started. So, vector data, a brief refresher. What is it? It's points, like coordinates. It's lines, like pairs or two or more points. And it's polygons, right? Connected lines that form a contiguous shape. Vector data represented by points, lines, and polygons. And it's represented, importantly, in tabular form, stored as tables. Now, we know that we can do a lot of operations to vector data. We can buffer it, right? We can add a fixed distance in any direction relative to a point, line, or a polygon and end up basically with a polygon. We got to reproject to buffer in the correct units, just remember that. We can dissolve, which is aggregating features based on specific attributes in the attribute table. For instance, we could be grouping these counties together on some other category, like political leaning or most common crop grown or anything really in that tabular data. There's also clipping, right? Extracting features from one layer based on the another layer. There's intersection, so taking the portions of features that overlap with another layer. Merging, so kind of sticking together two formerly separate data sets into a new one. And also not only the spatial data gets merged, but the tables, the tabular data behind the spatial data also gets merged. We can erase, right? We can kind of cut out features from one set of vector data on the basis of some other vector data. And we can do kind of more fancy operations too, like a symmetric difference operation, which kind of does an erase and an append at the same time. Basically, the areas that overlap get removed and the areas that don't overlap get saved. And then there's a union, so taking all of the features that overlap here and writing the output to a table and a feature class that consists of everything that overlaps the geometric union of the inputs. And then there's the identity. This one is not used terribly often, but computes the geometric intersection of two features, and then the features that overlap get written to the output. That overlap the identity, I should say. Now, we basically just cruise through all of these. There are plenty of resources out there to summarize and describe them in greater detail, and these are all things we've done in past lectures and class. So just keep them in mind as we go through today, knowing that there's some of the other things you can do with vector data. And we also talked about overlays, right? So overlay analysis is kind of putting these layers on top of one another to understand the relationships. So we can put points in polygons, we could put lines in polygons, we can put polygons in polygons, and this is going to become important as we think about one of our spatial join concepts later. Now, our geometric operations are used in our overlays, right? What is the basis of the overlay that we kind of want to inject into the operation and filter our features? So each of these different operations can be used as a different overlay. And importantly, they can cause a few different sets of errors, things like slivers, that can happen if you, for instance, intersect two misaligned vectors. So just be aware of some of these overlay errors that could occur from some of our geometric operations. So why are we interested in these types of analyses? Well, they kind of unlock various types of pattern analysis, which is pretty interesting techniques for understanding the spatial and statistical distribution of geographic phenomenon and uncovering trends and patterns, really commonly used in various fields like public health, criminology, urban planning, conservation. There's lots of different mathematic and computational techniques that are interesting and used here. I'm not going to go into these today, but I'm going to leave this up here for those who are curious to explore. And I just want to double click on the applications here, where pattern analysis and some of the overlay techniques that we're describing today are super useful and are actively utilized to do cutting edge research in a number of different fields. So, noting all of that, the importance of vector data and overlay analysis, let's move on to our tutorial section and a quick background on why we would want to do what we're going to do. And what we're going to do is called a tabular join. And essentially the scenario that this addresses is, what if we have some vector data that is plottable on a map? We can display it on our map and it describes some geographic phenomenon. And then we have some non-geospatial data that also corresponds to that geographic phenomenon, but it doesn't currently have any spatially enabled information, so we can't really put it on a map. So how do we visualize that non-geospatial data, and how can we combine it with existing geospatial data to visualize it? We need to do what's called a tabular join. So for instance, if we have some data describing county boundaries or census blocks, and then some tables describing population just in a spreadsheet, can we append the tabular population data to the geospatial data describing the county outlines so that we can make a map of, for instance, population density? That's what we're going to do today with a tabular join. And look at this little example that I'm showing on the left-hand side. It shows a type of tabular join where you notice some matching values in this code column of the right-hand table and the carrier column of the left-hand table. And what a tabular join does is it creates a new table where values in one column match values in another column, and there's a few different types of ways to do that. Here you will see for the row where the carrier and the code are both AA, we have the essentially overlap of these two columns. We have the three unique columns, and the carrier and code get written to the output as well. Now, for the column with AB that says AB is the carrier, for which there is no corresponding row in code, that gets written to the output, but the name column is blank since that doesn't exist here. And finally, the carrier called UA does exist in this other table, so we can write that as a new row to the database. And what we've essentially done is called a left join, okay? There are several different types of joins. The left join keeps rows in the first table and makes blank cells for any rows that don't have corresponding data in the right table. So that's what we just did here. We joined up the rows in the right-hand table for which there were matches in the code and carrier columns in the left table, and we made a blank cell for the row in the left table that didn't have any matches in the right-hand table. So that was a left join. A right join does the exact opposite thing. So we would keep rows from the right table instead of the left table that do not have matches. If you just flipped the order of the two tables in the left join example, you would end up with essentially a right join. A full or outer join keeps all the rows from both the tables and sets blank cells to the rows that don't have any corresponding values. So in this example, and it's the same example, there's no AB in the code column in the right-hand table, but there is in the left table, so that gets a row. And similarly, there's no HA in the carrier column, but there is in the code column, so that gets a row too, and we've got blank cells for where we don't have any matching values. So that's a full or an outer join. And there's also an inner join, which I didn't update the image here, but that keeps only the rows that have the corresponding values in both tables. So actually, if we were doing an inner join here, we wouldn't have the second row in this table and we wouldn't have the fourth row. We would only have the first row and the third row because both of those have values in both tables. So here's kind of a summary of how these joins work. And these are super easy to type into Google and get a reminder of if you need a refresher. And today we're doing an inner join, and we will specify that. So don't worry too much about this. Just know that these exist and you can look them up. So with that motivating context, let's get some data. We're going to get some tabular data describing population in census blocks, and we're going to get some spatial data describing the census block boundaries themselves, and we're going to join these two together and make a map. So you can go and download these two files in Canvas. I'm going to get them from these original data sources because I think it's important to be able to navigate some of these public data repositories and filter and actually download and work with some of this data that's not kind of pre-cleaned and given to you. So I'm going to go through it here, but it's kind of ready to go for you as these two files in Canvas. And let's get started. So this is a data table describing, I think, population demographics for the great state of New Jersey, from which I hail. It's taking a minute to load, so let's give that a second and let's go get the spatial data for, like I said, the great state of New Jersey. We're going to download that. It's telling me it is downloading in this zip file. Let's see if we can get this going better. This is being a little bit stubborn. And that's what you get for trying to rely on a government data set. So I'm just going to go to Canvas and get this. So it's in week 4. It's in, oh, you know what? I didn't even upload it yet. So I'm going to just grab it from my desktop. And this is the one we want, NJ pop data. All right, I'm going to put that in downloads. That's going to be the same file that you're going to be able to download on Canvas. And for the, oh, here we go. Table is too large to display. Great, we'll download it. Great, 2023, that seems fine. So let's go back to my Finder window. And did this download? Let's see. Let's just get 2022. Okay, that's telling me it downloaded. Great. It doesn't matter which year you pick. I'm going to put NJ pop data back in my desktop. Some live problem solving and debugging right there. So we have our zip files. Great. We need to unzip them or extract them. If you're on Windows, you will see they created these 2 new folders. We can expand them. There's a couple files here. The SHP file is the one that we're going to want to open in GIS, but we need all of these supporting files. Actually, we need at least these. Don't ask me why. They make a file format where you need multiple files to even open it. And then we're going to want this data table right here. So go ahead and fire up QGIS, and then open the shape file describing the county boundaries. It was called this, TL tract. If you're downloading from Canvas, it will have a much friendlier name. There it is, the greatest state in the nation, New Jersey. That's a joke. It is where I grew up, so I can make jokes like that. So we've got New Jersey. let's put down a base map just for good measure. I always like doing that. And as a reminder, if you're missing any panels or things that you like to see, like the layers or the browser, you can always get them back in View, Panels, and selecting what you need, like the processing toolbox. But we don't need any of that. We're going to load up this file from Canvas called the NJ population, basically. And we unzipped it right here. And this is the one we want, the data.csv. We don't want the table notes. We don't want the column metadata. We can go ahead and open that. And this little preview looks pretty good to me. We're going to tell this that this does not have a geometry, because it does not, right? We would use this to import like a CSV with latitude and longitude coordinates in the columns, but this doesn't have a geometry. And this looks good. So, okay, let us click add here. And little table got added to the layers panel. Great. So now we need essentially to join this layer to our geospatial data. We need to join this table to it. Now let's just open up the attribute tables here and just take a look at some of the data. So I just opened up the census blocks. And okay, see some different kind of headers. This looks like something that could be like an ID or an identifier. Yeah, we've got a whole bunch of different stuff. Let's open up the spreadsheet, the data table, and see what we got there. So I just opened that up. And we've got obviously our population data here. But we've got this column also called GeoID, and that actually looks super similar to this other column, right? GeoIDFQ. And it almost looks like the values, some of the values in this GeoID column, which I've just now sorted, can match potentially some of these columns in the GeoIDFQ column. Now, I noticed something funky with my data table, this one. It looks like the first row has the column headers. So I actually messed up a little bit importing this. We want to actually skip the first row of column headers, potentially, when we import this table. Because we can see that actually like the first row has the names. It doesn't have the values that we want our data table to have. It's got the names. So let me delete this. Again, live debugging and live problem solving on the fly. This is very real. Everybody makes errors and mistakes. And I'm just importing that same CSV again through the data source manager. And now I notice I have to hit this, change this to a 1. This is the number of header lines to discard field. And I can actually, I should have caught this before. I can look down at my previewed data table and I can see that the first row actually has the headers. So if I change this to a 1, then boom, this updated. Excellent. And you can see that the first row has actually the data that we want, and now the column headers are in the right place. So that's correct. I'm going to add that, close that down. We've got our correctly added data table. The column name that we want to join on is called geography now that we've imported it correctly. And the corresponding column in our spatial data, it's called GeoIDFQ. So let's go ahead and find our spatial join, or sorry, our tabular join tool. And you know what? I actually don't remember exactly where it is. So I'm going to open up the processing toolbox by going to panels, processing toolbox, and I'm just going to search join. And here we go. This is helpful. This is the tool that we want. Join attributes by field value. It's in vector general. Probably data management. Yep. Research, analysis, geometry, geoprocessing. Not sure. Anyway, it's here in our processing toolbox. Join attributes by field value. That's what we want. So search for join, find this tool, open it up. And here we've got several options. Our input layer should be our shapefile. Our table field, that's the field we want to join on, should be the one that we identified from the attribute table. That's GeoIDFQ, right? Going back to it. I'm going back to it by doing Control and the tilde, and I can toggle through my windows that are open here. So GeoIDFQ, that's correct. We know that the other field in the table is called geography. Now, join type. These are the different types of joins that we encountered, essentially. This is basically an inner join or an outer join. Let's do the inner join. That's fine. And this all looks fine to me, so I'm going to go ahead and click run. Now, check this out. It says 2,181 features from the input layer were successfully matched. That's good news. So let's get out of this stuff. We can check out our new joined layer, and we can open up the attribute table and see that, oh yeah, here's some of the population data from the previous table. There's a lot of it. There's a whole lot of it that made it into our new joined layer table. And actually, we can go ahead and visualize some of this, right? So if you go to properties, pull this over. It's a very long source right there, but symbology, perhaps graduated. And for value, maybe just total population. And let's do something like 10 classes. Go ahead and click classify, click apply, and then we're thinking. It's a lot of data. Click OK. Again, we're thinking, and there you have it. There is the population by census block in New Jersey. And we just created that from two previously separate data sets that were not previously connected. And we did that with a technique called a tabular join. So think about doing tabular joins in your homeworks. You will be doing them in project 2 and potentially in your final project as necessary. These techniques are very, very common, especially in doing things like demographic analysis, social science analysis. Honestly, this census data join is very common and is widely used in those fields. So, great. We just covered the tabular join, the famous tabular join. Very, very useful technique. Let's move on to a spatial join. Okay, so before we joined those data based on the values in a common column. Okay, but a spatial join joins values based on location instead. So it matches them by where they are on the map, right? So if you have two layers, one with points like storefronts or grocery stores or something, and then another with polygons like city boundaries or neighborhoods, you can essentially check where each store is located and add the name of the city or the borough or the neighborhood to the point layer on the basis of the polygon. And afterwards, each store will now know in which city it is, and it's all based on the location. And so here is kind of a visual map of what the spatial join can do. So if you have the first layer of properties, it consists of points, and here's the underlying data table. We can combine this. Actually, we're combining 3 data sets here with this spatial join. Points to these polygons, which are land use or zoning, industrial, commercial, residential, and natural. And then also the buildings in which these points fall. So our penultimate table, which is fully based on where in space these 3 layers overlap, looks like this. For each of these 4 points, we can join spatially the land use and the building to the original layer. So, given that, there are other techniques that are similar. So what's the difference between a join and a merge? A merge just combines the geometries of 2 layers. It doesn't necessarily join attributes based on location. So if you want to do something like count the number of weather stations in each county in California, or determine which county each weather station in California is in, a spatial join is probably what you want. So another example here, just on the difference between these two. I think it's clear, but there are more information if you'd like to compare spatial join versus other spatial operations. And there's similarly to the tabular join, there's the one-to-one join versus the one-to-many join. And essentially, this deals with handling multiple matches. And so if you do a one-to-one join, only one match will be selected. It's usually based on some spatial criteria that you can set. But if you do a one-to-many, that will keep every matching record. So you might end up with multiple rows describing the same feature in one of the input layers. And I think this will get clearer as we give an example. So, okay, here's a simple example where there's no ambiguity in assigning fields. Basically, for each of these points, we can append one of the polygon data to each point. But there are kind of more complicated examples, right? There are these simple joins. So asking the question, which county is each school in? A summary join, how many schools in each county? You can do it on the basis of distance. So which attraction is closest to each hotel? Interesting question. How many attractions are closest to each hotel? Like what is the most, what's the most happening hotel in downtown? I think you'll do an assignment in your homeworks on which subway stop in London has the most restaurants nearby. So just to sum it up, one-to-one joins simplify the output, one-to-many joins kind of expand the data. So let's get started with this tutorial and go ahead and do this. Go ahead and download these 2 files from Canvas, and we are going to do some spatial joins. So I'm going to download these 2. I'm going to download them as GeoJSONs. Great. GeoJSON, great. County boundaries, GeoJSON. All right, so let's go and open up QGIS. I'm going to get rid of everything from the tabular join so we can focus on our spatial join. Now, I don't think I need to unzip these files since they were downloaded as GeoJSON. I do need to refresh my downloads folder so as to update it. So what are we looking for here? Simus weather stations is 1. We're getting a transformation warning. That's fine. And county boundaries was the other. So let's fly to county boundaries. And let's pop the weather stations on top. We're back in our home state, probably the actual greatest state of the Union, California. So what we want to do is a spatial join now, right? And that's, we've already got it open. Join attributes by location. That's exactly what we want to do. So let's join. Let's say we want to join. Let's say we want to determine which county each weather station falls within. So let's spatial join the counties to the stations and check out what happens. And check this out. So you can see, what do these look like? Our geometric operations, right? So you can set what kind of relationship you want to join based on. I'm just going to say intersect. I think that is totally fine. But this allows for some quite rigorous comparisons between different spatial data sets. So, okay, before I do that, why don't I just open up the attribute tables here and take a look at what some of this stuff is. So these are the weather stations. Great, they've got some info, very cool. These are the county boundaries. Also got some info, they've got some codes, some census codes stuff, great. So let's join based on location now. And we're gonna join the counties to the stations and see what happens. So we got a warning, no spatial index exists. That's not a problem. So we joined 49 features, joined count 49. Cool, and we can check out our joined layer. So essentially, if we open up this attribute table, we can see each of these. So this was a one-to-many join because there are essentially duplicate shapes. So the first 3 rows here are the same polygon because there's 3 weather stations in this county, right? So similarly, 3 weather stations in Tehama County and 2 in Colusa. So we have multiple features written for each weather station in each county. And essentially what we've done is create a new row for each weather station that has the county geometry as an attribute. So what if we then reverse the order of the join, right? If we join stations to counties. Got the same warning, right? Now our joined layer is going to be consisting of points. And let's open up the attribute table here. We've got 265 rows. Is that the same number as in this data set? Yes, in fact it is, or about 265. I think there were slight difference there, but I think I will show you, I think we know why. So let's open up this attribute table. Very nice. Yes, we do have, in fact, the exact same number. And what have we essentially done? We have appended the county data in the attribute table to each row describing a weather station. So here is our county name as a new column along with our weather station data. So here's the weather station data. Here's our new county name, county code. This is the geo ID and the identifiers for the census data. And yeah, so we also have these 4 records at the end with no attributes in the county fields, right? These fields up here, these columns, all came from the county's data, and these are all null. So any guesses why those records might be null? Well, let's see if we can highlight those features and go check them out. So let's go one at a time. Let's go to this one, and we can, if we go to right click and zoom to selection, we can go close by, and let's put our county boundaries on. And look at that, we are slightly outside of the California county boundary right here, but this was included in the data set for whatever reason. Let's go see if that's true for the others. Oops, didn't mean to toggle editing. Let's go see if that's true for some of the others. So let's go all the way down to our null ones, and let's fly to this one. Yup, this one's in the south this time. Close to the Salton Sea, and I suspect our other 2 are these 2. Let's see if we can corroborate that by highlighting all these and seeing if they light up. Yup, so those are the features with null spatial join records because they don't overlap. So it makes a lot of sense why those attributes would be null. So to recap, we were able to combine data from weather stations and counties based on the geometric overlap between those 2 features using a technique called spatial joining. That is all for today, and I hope you have a good one.